Hello everyone, in this video we are going to learn how to find the last digit in case of two types of number. The first one is with base 10, which is generally called as a decimal number, and another one is base 2, which is generally called a binary number, or you can say the binary representation of a number. So for finding the last digit of any number with any base, first we have to understand the modulus operator. So you all know modulus operator. It just keeps the remainder on integer division. What I want to say is that suppose there is an integer a divided by integer b, then upon dividing integer division we will not take the decimal points in the division, only the integer parts, and the remainder is given by this operator. It is called as a modulus operator, remainder operator, we can call it as you wish. So let's move ahead with first base 10. Considering a number, suppose that 36, I want to find what last digit. So my last digit should be 6. So take any base 10 number, do its modulus by 10, and then it will give you what? It will give me the last digit. So this is my formula. Any base 10 number modulus 10 will give me the last digit. Example, let's take this example 36 modulus 10, it will give me 6. How? Just look here, 36 and then I'm dividing with 10. So 10 3 are 30 and then the remainder is 6. So it gives me 6 as my last digit. So it was for finding the last digit with base 10. What if we have to find the last digit with base 2? So let's just go ahead. Suppose that I have a base 2 number. For example, I am considering, let's suppose that I am considering 8. Now 8's binary representation will be 1 0 0 0. So this 8, we have to consider that this base 2 number must not be in its binary form. It must be in the decimal form. So base 2 must be in decimal form. Is modulus what? 2. Since the base is 2, so a modulus 2 will give me the what? The last digit in its binary representation. So I repeat, any number which is a decimal number modulus 2 will give me the last digit in its binary representation. Suppose that here 8 modulus 2 will give me 0, as 8 is completely divisible by 2. So and 0 is nothing but the last digit in the binary representation of the 8. Another example, suppose that I am considering 9. This 9 modulus 2 will give me 1. And what is this 1? It is nothing but the last digit in the binary representation of 9. And what's the binary representation of 9? It's 1001. So any number modulus 2 will give me the binary digit, last binary digit, and any number modulus 10 will give me its last digit in its decimal representation. So at last I want to generalize these two formulas. First one, any number base 10 modulus 10 will give me its last digit, and any number base which is represented in base 10 or any decimal number modulus 2 will give me what? Last digit, but what? Last digit in its binary representation. An example, for first one we can take 36 modulus 10, it will give me 6. And for this we can take an example, which is suppose that 9 modulus 2, it will give me 1, and which is nothing other than the last digits in the binary representation of the 9. That's all for the video. Thank you.